Bad news. I'm sorry. You have to change your entire application. Your boss said you want to use an LLM to add a new feature. Now your whole app that you've been working on for 6 months has to be a chat app. Everything's a chat app. Everything's a chat app. Everyone's talking to chat apps. We thought it was over in like the 2010s, but it's back, baby. We can fix this. You don't have to turn your application into a chat app to use an LLM to add features to your product. Today, we're going to talk about an example of using an LLM to add features to an existing application. Very excited. Let's talk about it in this episode of RAG Masters.
Hello, everybody, and welcome once again to RAG Masters, a show about, yes, of course, Retrieval Augmented Generation. I'm Neil Katz, a 20-year tech entrepreneur. With me, as always, my fabulous co-pilot, who's a human co-pilot, not an AI, Daniel Warfield, data scientist, RAG engineer, and today, a brilliant application developer, actually. And we're going to do something that is a little bit unexpected for RAG. We're not going to do a chat app. What are we working on today, Daniel?
All right, let's go to the slides. So at the very top, crystal clear, RAG is not just for chat applications. We're going to build, or I already built, and we're going to talk about what I built. We're going to go through a multimodal RAG powered application. We added RAG to an existing application in a real world use case that's actually useful.
We can now important.
Yeah, we can start a multi-million-dollar startup now, and then we're not going to do any more filming. Sorry, we're just going to do this now.
Steal this code.
Yeah, so please. So here's what I want to talk about. So first of all, I want to define the problem that we're solving. We started from a problem, an existing use case. So I wanted to define the problem. Then I want to define from a high level how we went about solving the problem. Then I wanted to kind of dig into the sort of solution and talk about how RAG was used to solve the problem. So let's clear out kind of like the unknowns first. What are we dealing with here? So we're dealing with Common Core, and this is kind of incidental. It could be a lot of different applications. You'll sense some themes probably, but we are dealing with a specific example, Common Core, which is the common set of standards that teachers use across the United States to standardize education.
So my kids are in this right now, and kids, I have one kid. I don't know why I added a plural. My kid is in this right now, and it is challenging because Common Core it's a different way of teaching math and English, but particular math that's different than how I grew up learning it. So it's hard for me to be her tutor, and it's different from how her teachers grew up learning it. And sometimes it's hard for them to figure out how to properly use and understand the Common Core curriculum to be effective in the classroom. So I'm pretty interested in, I think this is applicable to millions of people, what you're about to show us.
Yeah, hopefully. So a lot of people think of math education as a sequential set of steps. You like grade 1, 2, 3, 4, 5, whatever. And then within those, you have like little stepping stones, which is true. And that's, you're not learning more than one class at the same time. So it kind of feels that way. But under the hood, the math people know, like this is the Common Core, it's called the Coherence Map. They know that these concepts are interconnected together.
Like the incoherence map to me, frankly.
Yeah, but if you zoom in, it does kind of make sense. Like you have to learn addition and subtraction before you can learn this, and you have to learn about graphing and geometry before you can learn about that. So this coherence map is a map of all of the interrelated ideas.
So certain things have dependency. Certain lessons have dependency on other lessons, and it can be done linearly, but in a way it's not. And I think that's the complexity to this.
Yeah, and it's like you have to balance. I can only guess. I've done a little bit of teaching, but balancing this complex thing with other teachers and making sure everything's squared away, I imagine is a continual effort and a big source of collaboration for a lot of teachers.
Love this.
And there's a website called Archiving the Core that made an application around the coherence map. And actually, if we can share my screen real quick. And if I go to here, so am I sharing? Cool.
So you're clicking, yeah.
Fantastic. Okay. So this coherence map, it allows you to explore the coherence map, the one made by Archive the Core. So we can go to grade 4. We can talk about measurements. we can check out this standard, and we can get an idea of what this standard entails and also how it relates with different standards, which can be really useful in, exploring and building curriculum.
So in the middle here is the lesson, or at least the teacher's guide to how to think about the lesson with some examples. And on the left are the dependencies, the skill sets that the students need to have mastered to come into this lesson. Is that right?
I believe so, yeah. And then over here is the things they will need to learn. And over here is things that are typically taught at the same time. They're like a parallel things that are taught.
So on the right, if I master this lesson now, that can help me move into those things on the right, which require this as a dependency.
Exactly.
What it seems to be. Okay, so you can see there's a lot of complexity here for teachers.
Yeah. So if we can go
all for AI, right? We do.
Yeah. If we can go back to the slides. So yeah, you have a ton of complexity, right?
Yeah.
And we just saw this. So each of these sort of requirements, they really take the form of like a lot of them. They take a form of a sample problem. Like if you can solve this problem, you have passed this thing. And they have sometimes a few of them. Sometimes they have practice exams and practice problems, maybe 4 or 5, maybe 1 or 2, where it goes, okay, this is the type of stuff you have to know to like check the box for a student on this particular thing.
Okay.
Oh. Okay. So that's cool. And I explored this coherence map, and it's kind of difficult. What if you needed to find something specific? What if you needed to find a specific problem or a specific application or a specific lesson? You saw me, I actually flipped the order around. You saw me previously explore through this curriculum, and you have to click a bunch of stuff. You have to, click here, and then you move over to here. Imagine trying to find a specific problem in this complex net of interrelated things.
And, it would be the user here is most likely a teacher. Is that right?
Yeah, I imagine, or you, I guess, if you're confused about your student. But I was imagining teacher when I built this.
Okay,
for sure.
Cool.
So wouldn't it be cool if instead of like needing to navigate and search through this web of information to find a specific thing, wouldn't it be cool if you could textually ask some questions like, hey, I need an example of blank. Can you give me some good practice problems for a 3rd grader? Oh, I remember this example of measuring and there was like an eraser evolved. Can you like find that for me? Wouldn't it be cool if we can use those questions to enter into this web? So you can use the power of this network to explore around these sort of questions while simultaneously not needing to wade through this network to find them in the first place.
Yeah, love it.
That's the idea, and that's the solution. So let's check it out. I made a thing. So if we can go back to sharing my screen. Let me know if it's up.
It's up, Core Explorer.
All right, you can see this?
Mm-hmm.
All right, cool. So if I type something like, show me practice problems for counting with 1s, 10s, 100s, and then we search.
Yeah.
What we end up getting is not a chat response, but we end up getting, what's up?
Yeah, look at this. It's very cool. I'm excited. This is, you can do this in ChatGPT, but you just get you get 500 words of text.
Yeah, and they're structured weirdly. And if you wanted to like take an image and then give it to a student, then it would be, you need to make the image, right? Because even the most like cutting edge AI can't make this. Like these like coherent
can't count muffins and toast, not very well. No.
Yeah, there's no diffusion model that can pull that off, right? No. So we can like basically explore.
Any 3rd grader could draw that, but there is not yet an AI that can do this particular, Picasso on the page right here.
Yeah, it's funny what diffusion models are capable of and not capable of. It's really interesting. So like we can explore the PDF, but also we can explore. If I go over to here, we can also explore where the PDF came from. So we can explore the standard.
You can really see it, but you click that button and it opened it in a different tab in your browser.
Yes, exactly.
And it went right to the spot inside the coherence map system where this lesson was.
Yeah. Yeah. Great. And somewhere in this particular requirement, or standard is what it's technically called. Somewhere in this standard, is the PDF that we're just looking at. And we can look at different PDFs that are relevant to this particular application. And we can also look at some of the things that are required to understand this, and some of the things that this will help inform. So as a teacher, if you find a particular example that you think is interesting, you not only can look at the example, you can also find similar examples, and you can look at related content.
That's great. I mean, this is essentially a new interface on a cool piece of software that's already out there with great information underneath. And now instantly there's like an AI search on it that just feels like a totally different way of exploring this information.
Yeah, and it's actually wildly easy, which is crazy. If we can go back to the slides, I would love to talk about how it was actually built. So how did we do this, right?
And when I say we, I mean you.
Yeah, it was. I knocked it out in I think 3 or 4 days. It actually wasn't too bad. So So under the hood, you have all these standards, and all these standards have a bunch of PDFs. And basically, what we did was we uploaded those PDFs to a RAG system. We uploaded them to our RAG system. We're part of a company called iLevel. iLevel has a technology called GroundX. We use GroundX as our RAG system for this. So we uploaded the PDFs to GroundX. And then you can see in the slide, we have PDF 1, Standard 1, textual representation. What I mean by that is when you upload a document to GroundX, it doesn't just stick it in a bucket somewhere. It does a lot of complicated stuff. So if you have the document on the far left, when you upload it to GroundX, we pass it to our own parser called X-Ray.
Mm-hmm.
X-Ray breaks up the document.
Did you want to show the interactive version of that? Right now,
let me describe the high level, and then so we break it up into these components, right? And you can see them highlighted, right? Like the image is highlighted, these textual components are highlighted, and then each of these components get passed to different pipelines that then re-represent that into a textual representation. So yeah, I'd love to share my screen. Can you see this?
Yep, we can.
All right, fantastic. So I uploaded this document that contains an image, and if I click here, we can see some of the textual representations.
Just so people know what we're looking at here. This is what we call the X-ray viewer with our APIs. So you go back a second. The X-ray viewer, you can upload a document and then instantly see what our vision model does to identify all these different objects on the page. It then highlights those different objects in different colored boxes. So the graphical object, the cube on top, is like a yellow-green highlight. Our vision model figured out what that is and where it is. Then below it is text blocks, which are an orange. And now if you click on one of those objects, it'll show you the LLM-ready data, how it's been chunked and how it's been turned into content language models will understand, textual content.
Yeah, I couldn't have said it better myself. The only thing I'll add is that it does do different representations depending on the data, right?
So that was paragraphs. That was an easy one. But this is a figure. This is a graphic.
Yeah, and then it might choose to add a JSON representation. JSON representations are particularly powerful in things like tables, or maybe figures, like bar graphs. You can kind of represent that as textual information as a JSON object. So we take the document.
Let's stay on that for a second, just to make this really clear. So if you click on that cube and read this out, click on the cube. What's happening here? You can click on the JSON. For each slice, this is literally describing what this image is to a language model as if the language model is blind. For each slice, students must describe the cross-section shape using precise mathematical language and draw a diagram. That's the task description. Then there's the commentary, and then there's the kind of summary of what this visual object is. So, so this is all helpful to the language model. When you want to ask a question like Daniel asked, it can actually figure out A, what the answer is, and B, what graphical objects are helping to answer that question within these PDFs and where they're located, actually.
Yeah. You're the guy who sells this. Yeah, you're good at describing it. But yeah, it's really freaking cool, right? We take this document and we represent it as text, but not just like we turn it into like a text block. Like there's a lot of re-representation and baking in of context so that the information is interpretable by an LLM in a way that a human would find compelling, right? Like I can ask about this image now to a language model because the image is described textually, which is incredibly powerful because we're going to use that. If we can go back to the slides. So we have all these, so I'll go back to here. So we did this. When we upload our documents, we have all of our PDFs as textual representations, as these sort of rich, context-aware textual blocks. And then what we can do is we can, take those textual blocks and we can use GroundX based on the user's query to retrieve specific ones that are relevant to that query, right? So now we have all of these blocks that describe documents that are relevant to the user's query, which is great. Classic. We're still in classic RAG.
That's RAG in the bag right there. That's right down the plate for RAG. Yeah,
exactly. Now things get a little. So this is an example of the suggested text. We already kind of covered that. So now we get into something a little different. Normally in RAG, you answer the user's question explicitly. You take the retrieved information and you tell a language model, hey, we have this context, we have this question. You stick them both in a prompt and you tell the language model, answer the question based on the context that's been retrieved. Right. We're going to do something a little differently now. Here, this big prompt, and I won't read the whole thing, but basically what it's saying is, instead of answering the user's query, it says, I want you to find the responses that are perfectly relevant to the user's query. And I want you to re-represent them and reformat them so that there's 5 of them. And that, the most relevant ones at the top. And also I want you to restructure it as a JSON object. So we're asking the language model to do a bunch of stuff. It's really important to be clear. GroundX has a re-ranker under the hood. It does a lot of this, find if it's relevant, put the most relevant ones at the top. But we are using the world's most powerful language model, GPT-4o, to then re-rank again, which is a possible.
Those are fighting words, man. Those are fighting words when you say world's most powerful language model. I'm not gonna fight you. I'm not gonna be that guy. But there might be other people who would disagree with that, just to be clear. But it is the most powerful in the world for sure.
Among the pantheon, are you a fan of
pantheon of powerful? It is certainly there.
Are you a fan of Kratos or Zeus? But yeah,
like
so
gods, man.
So we're using a language model not to answer the question, but to re-represent the data. So we take this prompt, we take the user's query, and we take basically a structured object that's derivative from our parsed results our re-represented results from GroundX, as well as some other information. So we tell the language model, this is how we want you to represent the data. This is the query, and this is all the data that we want you to re-represent, essentially. And then you pass it to a language model, and this is what you get. You get a description of this particular object, and you get some URLs of where is the PDF and where in the coherence map can I find that PDF. These are all things that I gave the model in the prompt. So now if we go back to me sharing my screen, and then it broke. There we go. Hold on. Problems counting with ones, tens, or 100s. I'm just putting the same prompt in so we can see that JSON object that we defined previously is used to render these objects. And now suddenly we have it's still kind of like a chat app under the hood, sort of, but the user experience and the interaction, which is really the important part, is fundamentally different. And you can imagine this integrated maybe even more closely into an application. So it doesn't even really feel like chat at all.
Yeah, maybe. So you've sent that now structure. So you ask a question, you get these great retrievals. You ask the language model, instead of answering the question, create structured output out of these answers, out of these retrievals, basically. Like rank the retrievals and like the top 3 give me structured output. And then you send that to some front end piece of code that knows how to render those simple structured output you just got from the language model.
Yeah, exactly. And I will say, for the developers who are like, ooh, off to the races right now. That sounds sick. I can use that in my application. You totally can. It is a valid approach. There are some gotchas, right? Like the LLM might output weird stuff sometimes that's not parsable into JSON. There's a whole branch of application development around LLMs right now called LLM parsing, building systems that have a level of robustness around parsing. So you can either reprompt the model or re-represent the data, and you have built-in systems for handling those types of uncertainties.
I've data validation when it comes out. Is this properly structured or not? In some, you have to figure that out in some way.
Yeah, and that's a difficulty that's not as nearly as common in like a more traditional programmatic approach, but it's not unsurmountable. I think a lot of people don't even go at it as like application developers. They're like, there's no way it'll ever be consistent enough. I'll tell you personally, I've been building these types of like parsing systems that do this sort of complex output for a while. It's gotten so much better with like LangChain Pydantic parser and using LangGraph and their state graphs to sort of handle like parsing under the hood. It's very approachable and possible to build a robust system like this within an application. And then for the vague edge case, you just, handle that edge case. But 99% of the time it works like flawlessly, and it can be incredibly powerful.
What I love about this is it's a really interesting use case. It's very different than the typical chatbot, and it wasn't like this was a month of work. This was a couple of days. In particular, you did it with GroundX for extraction, GroundX for RAG, and then what did you use for the front end? View for the front end. And if you wanted to orchestrate that a little bit simpler for yourself, maybe add some data validation, you recommend adding like a LangGraph to help you do that.
Yeah, there's a million approaches.
Data validation, but LangGraph would be an easier way to build it.
Yeah, there's a million approaches. I would use LangGraph. Your mileage may vary, obviously. If you're competent in playing around with LLMs, you can build a parsing system yourself. But the Pydantic parser from LangChain and LangGraph is a way to structure some of that stuff. It is kind of a shortcut, and they have some pre-built prompts for language models, for specific language models, that have very good responses because it's an open source community. So they're always like working on this very specific problem. How do you prompt the model to consistently get a good output? So you can kind of leverage a lot of that open knowledge. Yeah.
Well, this is great. And we're going to, make sure we post the links to these different systems that you could use to put this together in the show notes. Do we also have the code itself that people can use, or that's maybe coming a little bit?
I think it'll be coming in a little bit. I gotta clean some stuff up before I really want to send it out. But yeah, it's basically done. So I'd love to, ship it out and then people can see. Actually, I would say, just so I don't have to do a ton of work, because I'd love to build other stuff. If you are interested in seeing this, leave a comment, ask about it, contact us. And then if enough of you contact us, maybe we'll talk to you individually. And if enough of you ask, then I'll, go through the effort of like really cleaning it up for a Git repo.
Right. Or if you don't mind like a messy room of a madman, we'll just give you the code as is. And
yeah, that too.
Build on it. We want you to be able to build on this as a Lego, as a building block of you building a really cool application. So as I say, like and subscribe. I always say I'm supposed to say that at the beginning of this show, not the end.
We're rebels.
We're at like our 20th episode. I'm going to figure this out eventually. Anything else? Any other comments you want to share with people on what they can do with this kind of technology?
You can use this technology to have an amazing day.
Very cool. Have an amazing day. Thank you, everybody. We'll see you next time on Ragmasters.